Quick intros. So I'm Marcus Robinson from Microsoft. Normally Alex does this session with me because it's with the company she works for, Callcredit, that we did this project with. So Alex is a systems build engineer at Callcredit. So I spent a lot of last 6 to 12 months, going and visiting customers and doing very short projects, generally up to a week, around open source technologies and implementing DevOps practices, with some element of Microsoft technologies, generally Microsoft Azure. And this is the story of when we went to Callcredit and what actually went on. So, Callcredit. So Callcredit are based in Leeds. I'm another guy from Leeds. Callcredit provide credit referencing services, okay, to third parties, be it e-commerce companies and things. They provide the software that integrates with the website, so then they get credit checks back on the companies. Primarily, they're very much a data-driven company, and they use a lot of Windows technology and .NET technology. Now, it's strange. I spent 15 years working 100% in Microsoft environments and pure Windows environments. I joined Microsoft about 2 years ago, and after 2 or 3 months, 90% of my time is working on Linux. This was the only Windows project I did over the last 6 to 12 months. So it's a bit of an anomaly. Just so I get an idea, who actually uses Windows on servers here? Anybody? Oh, we've got some, great. So a lot of what we've done is exactly the same if you're working on Linux containers as well. DevOps. So Callcredit have 100% embraced DevOps. Well, they actually have a DevOps team, bit of an anti-pattern. So they have a DevOps team that goes and looks at different products within the organization and optimizes the delivery of them. So the 100% in with DevOps to take it all very seriously, the culture side as well. This talk, there's a fair bit of culture in it. I normally just talk tech. The other way, Daniel normally does culture. I see Daniel do culture talks, and I'm around doing tech talks. But there is some tech in here as well. The product we actually went and did a hack on was called Numero. So Numero was a company that Callcredit acquired, based out of Stockport. Completely new to the organization. Okay, and the Numero software, again, it's integration with websites to provide credit referencing services. Callcredit works with some quite large companies. Okay, very much regulated by things like PCI DSS and security, high security regulations. What tech do Numero use? So, we did a bit of a fact-finding mission, and we'll come on to that in a bit more detail. But the platform is generally Windows, use SQL Server, .NET, IIS. There is some Java and Tomcat in there. We'll talk a little bit about that later. I was slightly confused what was going on. Some Node.js on IIS as well. Nginx. Tooling-wise, Visual Studio, Git, Jenkins, Redmine, Grunt. A number of package managers, including things like Artifactory. So that's what we knew to start. And one of the things we do when we go into these projects, we go and do a pre-day. Okay, we were given a scenario from Microsoft in the US. This is the sort of projects we want you to go and do. And a prerequisite of these projects was to go and do a day's value stream mapping. Okay, has anybody ever come across value stream mapping? Yeah, a few people. I'll be honest, I'd heard about it and seen people present on it. I'm a techie. Yeah, I'd generally veered away from that. But we went and we do value stream mapping. And we'll talk a bit about this. Before we actually start the mapping, though, this is in Numero's offices in Stockport. Okay, it was quite interesting that a lot of the Callcredit team had not met, or they'd spoken on the phone and things, but not met in person. So it was quite an interesting environment. A lot of fact-finding, not just for us as Microsoft, myself and my colleague, but also for the people from Callcredit. So first of all, they sketched out their architecture. It didn't look like this on the whiteboard, but this is what they provided as their architecture. I think there's I'm not going to go and explain it all, but there's a few things that I think it's worth talking about. First of all, the main part of the application is this core services over here. I call it a monolith. Okay, that's the core bit of the application. It's been around for years. Okay, and what they've been doing is starting to develop microservices. Any new functionality is going into microservices separately. So you can see these over here. And there's service contracts between the microservices and the data stores down there in SQL. So once we'd discussed the architecture, got our heads around what was going on, we looked at value stream mapping. Value stream mapping very much a retrospective exercise, talking about the past and what's happened. You can see on the left here, the start of things was, we got them to bullet point their general delivery pipeline. Okay, not just the development process, but right from the beginning, from the sales process. Okay, we want to look at the full end-to-end process. From value stream mapping is about getting that idea out into production. At what point does the customer, the user, benefit from that value? Okay, so we went right to the beginning, bulleted that out, and then starting at the end of the pipeline, okay, drew out the different stages and looked at what resource went into it, who was involved, how much time does it take, and gradually built this up. So you can see, got further and further. What you will see is some points on this map, I've got lots and lots of information, others not so much. Why? It depended on who was in the room. Okay. As Dan said earlier, it's very important to try and get all the decision makers and buy-in from everybody. And we had a good selection from the organisation, but you'll see the resulting map is thin in some areas. But from our point of view, we were going to do a hack around DevOps processes, so we were really more concerned with the development and release parts of the project. So mapped out this whole pipeline, looked at the timings, how much time spent, and I'm going to dig into this a bit more detail, and then handed over the red pen. So I just facilitated this. It was Callcredit and Numero who did this. There's different types of waste, things like manual processes, task switching, unnecessary meetings. I'm trying to think. Task switching, like manual processes, waste, so work that's done, there's no point in doing it. Wait time. So passed the red pen around, and people went on, wrote the letter, for W for waste, and to mark out areas that things could potentially be improved. There was lots of waste, and it was great. Callcredit and Numero were very open to this. A lot of organisations are a bit, no, what we do it for a reason. We've always done it that way. There's nothing wrong with it. But Callcredit and Numero were very open-minded. You can see, especially in the development process, there was a lot of manual processes going on. Openness is really important. Look, there's no blame culture. We're just going to get everything out there. And then the time everybody was waiting for. So all day people have wanted to talk about solutions. And I said, no, we're looking at the past. I'm not going to talk about containers. I'm not going to talk about platform as a service. I'm not going to talk about Azure. We're looking at the past. Okay. But at this point in time for solutions. And people took the green pens. Okay. And everybody got involved and wrote down ideas on how things could be improved. Okay. And how this time from getting the ideas from inception to production could be reduced. Now the important thing is it's very easy for people to say when you're doing the value stream mapping, it depends. So we actually got them to pull out a specific scenario. Okay, of a certain feature that they released. Okay, so people sometimes use new features. The other sort of idea we do is bugs. So when there's a bug or a service outage, do a value stream map of the process that was used to resolve that outage. But in this instance, it was a new feature. It was a new widget on a website. Okay, and the development process actually went on for quite a long time, as we'll see. So this was the full value stream map. Starting with a sales opportunity, 8 weeks. Then they did a proof of concept, 3 weeks, 2 weeks. There was 18 weeks of development. Okay, went on. I think the sprints were the 2 week sprints, and then out into release and deployment. Now you can see support. I said, what happens once it's released? There's actually nobody from the support team in the room. So there's not a lot known about the support process. Again, down in this proof of concept and sales, we're very thin on information. Okay, ideally, we'd have those people in the room too. Okay, but I didn't actually realise that the scenario we were talking about was going to be quite reliant on that. Okay, but you can see how we've built this map up. This bit at the bottom, we just used the whiteboard down there to explain a bit more about their Jenkins processes. So they're using Jenkins for build and release, which we'll come on to. But in total, the total process time to get this feature into production was 34 weeks. Okay. So the first thing to point out is issues can be introduced a long time before there's any technology involved. Alex came up with this not on the lorry. The sales team were trying to get a new client or get a contract extended, and the client said, we want feature X. And they just said, yes, we can do that. Yeah. There we go. And actually the sales team went and found somebody, an individual developer, to go and do the proof of concept. Yeah. So the right technical staff have not been involved. Okay, so that was the first thing. Right at the beginning of the sales stage, we've got a problem. But I wanted to dig into the development. First thing, multiple manual deployments. All these little M's, we've got lots. People are deploying code manually into servers, okay? Be it developers setting up development environments, be it testers setting up test environments. And these blue Ds, I think, were full deployments of multiple VMs, what people were doing manually in every sprint. So there's lots of waiting, lots of manual steps, and actually there's a lot of time wasted actually not producing much, which meant this process kept iterating and iterating. Look, I'm picking out problems. They've got a great software application, and it was great that when we went to Callcredit and Numero, they were very, very open about what's going on, okay, and we could look at these problems. But they were operating, they were delivering and releasing software, and got good customers. But you can see there's obviously some room that we could for improvement. So Jenkins, the builds were taking about 8 hours in Jenkins. Okay, failures were common. So they would go home, leave the build running. If they got in the morning and it had failed, they'd have to kick it off again. Could take 16 hours if it worked second time. So there's obviously a few issues. A lot of this was due to technical debt. A lot of redundant tests in there, no longer required, but they just hadn't got the time to go and dig into the builds and work out what was going on. There's also queued builds due to hardware bottlenecks. The SAN was being hammered. So it was making this process really, really slow. And actually, I'll just jump back here. So one of the drivers for us as Microsoft in doing these projects was to show open source technologies running on Microsoft Azure. And I asked them to list the open source projects that they were using. Okay, they got down to about here. And I said, how many have you got? They used about 200. Okay, so all these dependencies were being pulled in as well. Sorry, wrong way. So then we went to talk about release. So they got, this software is deployed onto customer sites because of security. They also do some hosting, okay? But there was about 30 different sites it was being deployed to, okay? 60 different versions of the application. Each customer that wanted different features would end up on a slightly different version sometimes, or if they weren't paying for support, they wouldn't get the new version. They'd stay on the old version. So there was a lot of manual deployment, often with copy and paste over remote desktop. Okay. Obviously introduces errors. There was Octopus on one site, so they're trying to move towards using Octopus deploy. Multiple customers means multiple deploys. They're actually doing this manual process 30 times. Okay. And we look at wait time when we're doing value stream mapping. And I said, well, when do all the customers get your latest features? It depends if they're paying for them. So actually, I put infinity in there. I said, well, they're never going to see the value. So it's something else to look at. So that was the value stream mapping exercise. We then had to think about what we were going to work on. Callcredit's requirements, it had to be portable. Deployment anywhere on-prem to Azure or to another public cloud. They want to be able to push and update once and be able to update all live instances. Quickly reproduce any bespoke customer solutions. So if a customer's using version 1.4 of the software, they want to be able to spin up 1.4 in a development environment and do some testing to see what's going on. They also wanted to have something that was repeatable that they could use with other software products they were delivering. So all the work that goes into building the pipelines, they want to be able to reuse. It had to be scalable and obviously resilient. Containers was the most obvious thing to try. Now, I've got to say we had a little bit of a debate because I was like, look, think about platform as a service, serverless offerings, okay? But actually, when we go back into these requirements, not being stuck to a particular cloud provider or anything was really important to them and being able to deploy on-prem. So containers seemed to make sense. The other thing was, this discussion was February this year. Windows containers were pretty raw at this point in time. They weren't supported, they were only just starting to appear. So I'd actually not done much work with them because I stayed clear because they weren't quite ready. So this was the first time we really got hands-on with them. So we do a hackathon, okay, or a hack. We identified what were the minimal viable components to get the solution up and running. But again, what Daniel says, start small. Okay, they needed the database. We'll talk a bit about that. They needed core services, which is the monolith, and they needed the identity component. So before the hack, it was great that the guys at Numero went and built the solution from scratch, confirmed they had all the prerequisites, created a pipeline in Octopus to make sure everything worked, set up an Azure sandbox, set up Visual Studio Team Services, VSTS, I'll talk about that in a second, and imported their existing Git repos into Visual Studio Team Services. So that was really good. Okay, it meant when we got into the hack was 3 days. Okay, we got 3 days scheduled to do this. Okay, Daniel told you how to do things right. Yeah, this was a hack. We followed some best practices. Other things, as you'll see, we just got things up and running. Okay, it's proof of concept. Yeah, for those who aren't aware of what Visual Studio Team Services and Team Foundation Server are, these are the only two sort of slightly marketing slides. Visual Studio Team Services, the hosted version of Team Foundation Server, has a whole load of features in there, such as work tracking, Kanban, things like that, source control, build, release management, testing, monitoring. I get shot for this, saying this at DevOps groups, but I like to say it's, from a tooling point of view, DevOps in a box. Okay, indeed, yeah. But yeah, I do say that quite a lot. The main differences between TFS and Visual Studio Team Services is Visual Studio Team Services gets updated every month. TFS is quarterly updates. Okay, same product, it's just the release cadence is different. So why VSTS? So Alex nodded us this slide. I wanted to use Jenkins, okay, because the purpose of going and working with Callcredit was to demonstrate open source technologies on Azure. Okay, I want to show all you people who uses Jenkins. Yeah, all you people that look, Jenkins works great on Azure, which it does. Okay, but they wanted to use Visual Studio Team Services, which, to be honest, I didn't complain about too much, you know, because we're very familiar with it and we know exactly what it can do. So Callcredit, not Numero, Callcredit were using TFS, and they wanted to bring Numero into the same way of working. It's useful to have a cloud service. Yeah, there was a remote site, you know, wanted to all work together. They also have some people over in Lithuania with Callcredit, so a cloud service was beneficial. They're already internally wanting to evaluate Visual Studio Team Services. Don't have to worry about updates, it's platform as a service, or software as a service, I guess. And it gets the updates first. So they really wanted to take this opportunity to have a look at Visual Studio Team Services. So the hack, this is us hacking, okay, in Lee's offices. My colleague Ross, and then a few of the Numero team and Callcredit team. We're in this room for 3 days, quite long hours. So what happened? So the aims, as I say, database, core services, and identity. And we decided we were going to use Docker containers. We were just going to create 2 environments, a test and a live. This is proof of concept, okay? And we were going to use Azure, obviously. Yeah. And we wanted some sort of monitoring on there. First of all, Azure Dev Test Labs. So everyone was on corporate lockdown workstations. We were using Windows containers. It needed Windows Server 2016. How can we give them access to this? So on Azure, we have this feature called Dev Test Labs. And what it enables is to provide each developer with a sandbox. So you create a Dev Test Labs. It's based on virtual machines, or we can have a number of virtual machines and a template. You can schedule when they're going to shut down, so they'll all turn off at the end of the day to save some money. So you go and configure, you add a virtual machine. You say, what's the base image? So we do have Windows Server with Docker, but we also wanted Visual Studio Enterprise 2017 because it's got some Docker support in there. So we couldn't have an image with both. So we decided to go, because Visual Studio takes a long time to install, go with that. Visual Studio Enterprise, chose the VM size and everything. Choose the IP address in. Each one gets a public IP so they can remote desktop into it. An expiration date. All these machines are going to get scrapped at the end of the hack, okay, automatically by putting a date in there. And make it claimable. So we created a pool of about 10 machines. People logged onto Azure and say, I want that one. It puts it under their account, and then they can connect to it and get coding. Choose the virtual machine sizes, and we can limit what sizes different users can use. And you choose artifacts. So it's like creating an image. If you think of it configuration management-wise, you say which artifacts do we want to be installed on this server. Chocolatey, people might come across Chocolatey, package manager for Windows, so we use Chocolatey to install a lot of the artifacts. And we create this reusable formula. And then people can, when they get it, they can start and stop it and do what they want. So the first output, the hack. We needed Docker on these machines. Docker on Windows Server was new. So a couple of days before the hack, I went and created a Docker artifact. So if you use Dev Test Labs on Azure, you'll see this in the portal. It's an open source repo, so I created this, submit it to the repo. They merged it for me. So you can go on there and you can install this artifact and you get Docker support on Windows Server. So that was the first output, which was great before we got started. So on the first morning of the hack, everybody had a brand new dev machine, not restricted by corporate firewall, okay, which was useful. We're doing a hack, yeah. So a bit quick talk on Windows servers and Windows containers and Linux containers. Windows container, this has changed now, but I always used to say Windows containers only run on Windows Server and Linux containers only run on Linux servers. But now we can also run Linux containers on Windows servers, okay. Different base images, okay, different kernels, okay, but follows the same standards. Docker images, a Docker registry can support both Windows and Linux images. We use the same Docker CLI, just changed the host we're communicating with, Docker engine we're communicating with, but it's different technologies. Dan's talked a lot about release process. This is in a nutshell. Why do we like using containers for continuous delivery? Developers can get on with developing, and then the ops team can look after the automation and remediation and monitoring, okay, and feedback, and very quickly get updates out there and any issues resolved, okay. So these are different components in the application. That's the monolith, some of the new stuff, and this is what we went and hacked. So I'm going to run through some of the Docker files. So the key thing to a lot of these hacks is making sure the organization has the right build scripts, okay. If they've got doing manual deployments and we go in and we expect to get this done in 3 days, we're not going to get anywhere. So luckily, Numero went away and made sure they had everything scripted. Didn't want to use any base images off Docker Hub, worried about security, decided to build all their own, which is very valid. So we're using the Windows Server core base image. Okay, there's also a Nano Server base image, born for the cloud, but has less functionality in there. But because we were doing lift and shift, we needed as much Windows Server functionality as we could. Installed IIS using PowerShell. This is a script that monitors the IIS service, and if it stops, restarts the container, restarts the service. If it won't restart, restarts the container. It makes sure there's something interactive running. Okay, there's nothing interactive, the container will just stop. So that's what that's for. So again, so they actually had Tomcat and Java in the same server as IIS. Okay, I said, can we split this out? But actually it was quite tightly linked. We had not got time to go in and change this. So based off the IIS and .NET 4.5 image, we added some Java and Tomcat functionality. We just used their existing script they're using for installing and configuring Tomcat and Java. Very easy. Okay. Without this, we might have struggled. But we just reuse their existing scripts. This is the monolith. Drop the artifacts in there. There was a bit of a DNS bug in Windows Server. I believe that's now resolved. And with help of Elton from Docker, we got that sorted. And again, this is what does all the work. This one install script. Okay, we're just using their existing scripts from their VM-based deployments to get going. Node.js. So again, just using standard installers, running the process, copying an installer in, and running the process. Okay, nothing particularly special. It looks nice and easy. It took us a little while, because all this was brand new. There's no documentation or anything. But if anybody watched DockerCon, anybody watched the DockerCon streams, and they're talking about the modernising traditional apps and how they do them in 5 days, similar sort of thing. Yeah, and SQL. So data. Do we store data in a container? No, not really. Ideally, if they're going to deploy this on Azure, would use the SQL database service, or they might have existing SQL clusters on site. But for the purpose of the hack, all the devs need to be coding and using their own database. So we put SQL Server into a container. Again, it didn't exist out there to pull off Docker Hub. It does now. So we got that installed. So everybody could then have SQL and deploy the application. And Nginx. Yeah, I was surprised they're using Nginx on Windows, but yeah, absolutely. So they're using Nginx as a reverse proxy. And SSL offload. Okay, again, put it into the container. So, build and release. How am I doing for time, Matt? Right, cool. Again, this is normally about 45-minute sessions, so I've got my foot down. So this is Visual Studio Team Services, doing build definitions. It's task-based. Okay, so we can add existing tasks. So again, we looked at, this is for their identity component, we looked at what they got in their Jenkins pipelines, npm install. They got a lot of grunt scripts used, so we just use those existing grunt scripts. Okay. Testing. It's a hack, so we actually disabled the tests. You know, because they were taking a long time, there was failures. We just wanted to get something up and running. So following the exact same build process they were using, and then the only bits that are, you know, Docker specific is these two down here. Build the image and push the image, which we'll talk a little bit more about. So building the image, this is the Docker task to get in VSTS. It was version 0 point something. You know, we've come on a bit since then. Using Azure Container Registry, so we can set up a connection. You know, it's like Docker Hub, but on Azure for private registry. Path to the Docker file. And the image name is the repository name. So we had a different repository for each container. And with the build ID, so we have environment variables in Visual Studio Team Services. Each build gets a new ID. We can change the format. And this is the tag of the image. So each image gets tagged with the build ID, so we know exactly what we're deploying. Okay, and qualify image name is to ensure the registry is prefixed. So when we go and push it up, it knows where it's going to go. And then push the image up to Azure Container Registry. Again, using that same build ID. Okay, to ensure it's the right image version. It's getting pushed up. Latest. Yeah. Latest, you know, we can tag images with latest, or if we don't tag them, I think they go up as latest. If you don't provide a tag when you pull an image, you'll get the latest version. Don't do this in production, because you don't actually know what version you're pulling. Yeah. Who might have updated that image? You don't know what version you're deploying, what's in there. Okay. But it's a hack. Yeah. So we selected the checkbox tag with latest, because we wanted people who were developing separately on their own machines just be able to pull an image and get the latest version and not worry about, you know, is this the latest, you know, got the latest fixes in, because we're all on different machines, continuous working away. But very clear, not a good idea in production. Yeah. So this is the build logs. So you can get all the output of all the build stages in Visual Studio Team Services. They're like this. You never see everything step by step exactly what was going on without downloading any logs. Or if you want, you can download the logs in a zip file. Yeah, and also got the test status. So you can see when we did have some tests enabled, you can see the test status, go and drill and see the test results. And the deployment status to the different test and live environment. Okay. Yeah, so celebration, everything built, okay, and was ready to be deployed. Built, not released, or deployed. So let's talk about release, which decided to use Docker Swarm and Compose. Would my decision be different now? Probably, yeah. But why at the time did we choose? Need to deploy to a single VM for the devs. And also some sites were using a single VM. If we're using Kubernetes, we'd need a Linux server for orchestration. Okay, added complexity. So it just made sense to use swarms included in Windows Server, just do swarm in it and you're up and running. Okay, so that's why we use Swarm, and hence we use Compose. Okay. And again, we created a Compose file. I'm not going to drill into that. With the different images, ports, environment variables, dependencies, what needs to spin up in what order. And the build IDs. So the build ID gets passed in, which you'll see here actually. So these are the two release environments. We've got a test and a live environment. We did create some Selenium tests to run post-deploy. And we can see over here, we're actually using, I think, Docker Compose at this point in time, but use Docker Stack Deploy, isn't it, to deploy when you're on Swarm. Is there anything else interesting here? So we do in the Compose file have placeholders for the environment variables. So when you create a release, it's based on a number of builds. So it might be their vouch container version 5, their core services version 30, and those build IDs are passed through into release, so it knows which versions you're releasing. Yeah, we actually set up continuous deployment to trigger on the Compose file updates. Because there were so many iterations of the containers, we didn't want it to be continuously deploying every few seconds. Okay, but again in production, we'd probably trigger on the build of the separate container. So each time a container's updated and an image gets pushed, we would update, do a new release to a test environment. Yeah, and between the different environments, we can do manual approvals and things, but again, because it was a hack, we just had it automatically deploying every single time. Monitoring. Chose to use Microsoft Operations Management Suite. Callcredit wanted to look at this. This is a Microsoft product that's part of Azure. It's an agent you install on all the hosts, and it collects logs from the Docker hosts. It works with Windows and Linux and integrates in the Azure portal. But Callcredit were already using it, Elk. So a couple of people that look after monitoring actually looked at exporting the logs from Operations Manager into Elk. Okay, so they could have a single dashboard, but actually this also using the more Azure native technologies, because you get a bit more insight into what's going on Azure. Yeah, so it worked. Okay, released, and it all came up. Well, no, it didn't. Okay, I was, day 3 on the Wednesday at 6 o'clock. I was in the Town Hall Tavern in Leeds. While everybody else was having a pint, trying to, what's going on? Why won't it come up? When they got back to the office on the Monday after, they spoke to a couple of other developers that weren't on the hack, and they found a permissions issue on a file in www or something like that was being deployed in one of the build scripts. They changed that, and it came up. Okay, I'd spent a good day trying to fix this, till midnight. But yeah, no, it worked. So what were the next steps? So they documented and scripted as much as possible. Okay, automated as many of the steps as possible, and also shouted about it internally. Get everybody else on board. Also externally. So Callcredit have been great. Alex has been great coming to events like this, saying, "Look, this is what we did." This was very early days of Windows containers, showing what could be done. And then the next choice is orchestration. So we'd use Swarm. I'd push them in the direction of Swarm at the time, because again, Swarm with Windows, you don't need any Linux knowledge. Might have a bit of a different opinion now. Kubernetes might be the way forward. It seems to have the most momentum with community and everything, and we've got a lot of investment at Microsoft in Kubernetes. Service Fabric. So anybody heard of Service Fabric? Yeah, a few people. So Service Fabric's Microsoft's. Well, it has programming models. Runs a lot of the Azure services, Skype, Power BI, things like that. So it's real mission critical workloads, and it now supports containers. Okay, and Callcredit are using Service Fabric elsewhere in the organisation. So to me, it sort of makes sense maybe for them to use Service Fabric because it fits in with their existing technology stack. But I think they want to use Kubernetes because it's cool. But again, is that the right choice or not? Yeah, going back to requirements. They've got something that was portable. Deploy it where they want. Just give the customer a compose file and the registry credentials, and they get the version of the application they require. Push and update once, and it updates all live instances. Again, using the single compose file. Replicate any bespoke custom solution. We know the customer's on version, let's say 1, 2 of each container. Just pop that into the compose file, and they get the exact same version that customer's using. Okay, whereas before, that was a good week's worth of work. Getting new servers provisioned, getting the right artifacts. And it's something they can repeat. We can do this with other products. Scalability and resilience, nearly a bit of work. Very much early days. And then what they've been doing since the hack, they've looked at re-engineering the delivery process in Jenkins as well. So they've been containerizing some of the Jenkins build agents and things. Trying to split up this monolith a little bit, because it was very much heavy lifting. Look at database re-engineering, rationalization of the test suite, trying to reduce these build times down. Make sure the whole solution can be deployed automatically. Prove it can be portable, deploy it on various environments, on-prem, Azure, I guess AWS. Add a customer's config. Everything we'd done, there was no real data in there. It was just make-believe, and it's very much configuration-driven, the product. The user interfaces are based on the customer's configuration, so they need to try it with some customers, and they want to get it live. Okay, and they are very much working towards this. And then the next step is they're going to move on to the next product and try and repeat the process. Okay, so I hope you found that useful. That was one of our early endeavors into Windows containers and continuous delivery. So if anybody, there's some resources there, actually case studies. I'll just show you this very quickly. I know I've probably gone over a little bit. If you want to know more about this, all the technical resources are, have I got on the internet? Yeah. So on this GitHub repo, microsoft.github.io/tech case studies, you can choose your technology, but if I type, say, Callcredit, I'll just show technology. So we've got different technologies. So DevOps is in there. You see DevOps is in there down there. I'll just apply that filter. You see I actually did a technical write-up for every project we did, and this whole process, all the artifacts and everything are all in there, all the compose files, if you're interested. All the code is all there. Okay, and there's loads of these from all over the world. We've been doing these projects, and you can get those resources. Yeah, and if you want to know more about Microsoft and DevOps, there's some links to videos there. If you've got any questions, drop me an email or Send me a tweet. And moving forward, we're going to be looking at potentially, if someone's got really interesting Kubernetes projects they want to give a go on Azure, it's got to be really interesting because we put quite a lot of resource into these, or big name, something exciting, then that's what we're looking to do over the next 6 to 12 months, so give me a shout. All right, thanks very much.
Any questions for Mark? The slides
Go on.
hopefully a good one. Was there any demand to use, you talked about the client config being the data, the states that you want to introduce at some point. Have we got that right? Was there any demand to use the sort of production workloads or use production data?
What, on the hack?
In
general, absolutely. That's what they're doing now. They're validating this with real data and production data. For the purpose of the hack, we had to bypass security and everything, so it was just a case of let's get the minimal components we could, and we've done this with a variety of financial organisations. Just get the components without any data and get things up and running. But no, absolutely, it'll be validated fully with real world data, and they want to go live in the next few months, with first customers with this. Yeah, cool.
If somebody using a different technology stack,
Yep.
the migration path for them.
If someone's using a different technology stack, as far as CI/CD or as far as contain, from what sort of technology stack?
Well, this is Microsoft stuff.
Yeah, so we do the same sort of thing. So I say this was the only Windows-based project I did last year. I've done Python projects, Python and Flask and things like that. I've done Java projects. So yeah, the tooling is the same. It's Docker. We can use Visual Studio Team Services. You can use Jenkins or whichever CI/CD. But the actual processes and tooling, as Daniel's talking, everything in Daniel's talk, it's transferable. And that's the cool thing about Docker. And what Docker have enabled is this standard way of working.